I'm Dr. Sahar Afshan, and today we are going to be doing biostatistics part two, formulas, measurement, and calculations. Last time we did part one, it was basic concepts, some graphs, presentation, and basic definitions of biostatistics. Statistics is an interesting topic, but students usually avoid due to the dangerous formulas that are present there. The formulas are pretty big and they seem complicated too complicated to understand. But otherwise, once the concepts are clear, um, they're pretty interesting. So today we're going to be starting from the basic formulas, measurements, and calculation that are commonly used in community medicine, and also that are relevant to fourth year medical students. So types of measurements, kind of average and center tendency, and measures of dispersion. That is something that is graphical presentation or something that is on a wider scale or that we have. Kinds of average, there are three types of average: mean, mode, median. You must have studied this previously in your other classes as well, including I think we studied it in matricular grade 10 and physics as well. I remember as far as. So mean, mode, median, some of these terms are very familiar to us and we have gone through them. Others are measures of dispersion. That includes range, mean deviation, standard deviation, coefficient of variation. These might seem new and complicated. Trust me, they're easy and we're going to dive into them. So what is a mean? Mean is, or other words, average. Arithmetic mean is the simplest and the most widely used measure of a mean or average. It simply involves if you are given a set of data, 10 5 numbers, you just calculate all of them together, add them up, and divide them by the number of items that are present. Suppose there are 10 numbers present or 5 numbers present. We're going to be adding 5 of them and dividing them by 5. If there are 6 numbers, we're going to be adding 6 of them and dividing them by 6. So if we get the average mean of that data. Mean is very important from biostatistics, and we get to see this in research papers a lot. What is the mean of the population, the mean of diabetic range, whatever. Mean is commonly used term, and it's easy to calculate. What is mode? Mode is the number that is most frequently seen in a data. Okay. For example, I have an example here, set of data 1, 3, 6, 6, 6, 6, 7, 7, 12, 12, 12. In this, 6 is most commonly expressed. That number that is mostly expressed, most commonly that occurs in the data is called the mode. We take the mode as that. On the other hand, if two numbers happen to be similarly present in the data, but which commonly doesn't happen, suppose here if 6 and 7, two numbers were equally present 4 times, we would take 6 and 7 and take a average of these two. So that is also called mode. But normally, mode is usually one number that is present. And it's an important information about a random variable or a population. Any specific, usually the number of, suppose we are calculating how many, in terms of gender and whole numbers that we have, male, female. In these variables, we normally express mode. Median is a very simple, another word that, another term that we are used to. It's taking the middle or the number that comes in between a set of data. Now, how do we calculate a mean? Median needs some calculation. First of all, if there's a set of data, we have to arrange it in an ascending order in a certain pattern. Once we have that pattern in a ascending order, then we calculate that number from both sides, and the middle number that comes in between is the median. If suppose we have two numbers that are coming in between, so we take the average of those two. That means calculate them both and divide it by, add them both and divide it by 2. So that is called the median in biostatistics. Range. Range means the highest and the lowest value and the difference between them. Suppose, I'm sorry, suppose there it's a set of number between 10 and 5. So what is the range, the area between these two? Range is used in a number of ways, especially in terms of defining a space, an area, um, um, any suppose diabetic range, glucose, any, basically it's usually used for measurement, um, specifically numbers, range between, especially in terms of research papers that we see, the range of patients age between 33 to 74, or range between if a certain vitamin D levels in certain. So how do we calculate the range? It's basically the highest number, the lowest number, and the difference of those two. So that is called the range in terms of biostatistics. You will be seeing this a lot in research papers and data collection. It's a very easy way to calculate it. Mean deviation. Now this is becoming easy. We're stepping up, right? And this would become a little complicated. It sounds complicated, but it's not. Since we know now what is mean, we know the average, the average number. So how far an average all values are from the middle. It's especially nowadays when we read the research papers and all the other calculations. They are usually done on spread Excel sheets. So there is already an inbuilt formula in spread Excel that when we put a set of numbers there, it's very easy to calculate, because then we don't really apply a calculation. So also mean deviation is an average overall values from the middle. Okay. Next is standard deviation. Standard deviation is very commonly used in biostatistics, and it's an important term. It's a measure of how spread out numbers are, how far they are. It defines a certain range of what we are seeing. Now, why is it so important? Because a lot of formulas are based on standard deviation. We have to calculate the standard deviation of the numbers first. In terms of data, you will see it's presented by the letter sigma. So once it's presented by the letter sigma, you would be very commonly seeing this in article journals, standard deviation, standard deviation. Why is it important? It kind of tells you the range from minus to plus. We'll go into the formula next. So here I got it from an internet, very nice picture. I don't remember where I took it from. But anyways, standard deviation, we have two types, because it's a way of calculating the data, and data is calculated in terms of research. So it has either it's a sample or the population that we are trying to analyze and calculate. In terms of sample, now the sigma is and the just below the population, we have the sigma. So the sigma is basically, that is the standard deviation, is basically the square root of x minus mu divided by n. Capital N is the number of the population. How many people were there? I mean, because we are calculating population here for standard deviation. So N defines the number of the population. 10 people, 20 people, 500 people. What was the set of data that was calculated? What was the sample of the population that we had? So N defines the sample of the population. This sign, X is mean, and mu is the average and square root. So that gives, again, I would say normally so far, that now that I'm doing all the standard deviations, we are doing on an Excel spreadsheet, and there's already an inbuilt formula for it. So it doesn't turn out like this so far, but it's an under root of X minus mu divided by total population. Now, what is coefficient of variation? This is another term that you would be seeing frequently or would be facing the formula. From medical students' point of view, that is fourth year students' point of view, I would say it's important to learn the formulas right now, just to have the concept, what the variables or what the symbols stand for. At this level, fourth year medical students, you wouldn't really be doing any calculations. And just to have an idea, if you're reading journal articles, what it is about that what you're reading should make sense to you, right? So the coefficient of variation is a measure of relative variability. It is the ratio of the standard deviation, and it's usually expressed in terms of percentage. So coefficient is sigma upon mu. That is mean. Standard deviation divided by mean. Mu is mean, right? Mu is the U sign that we are seeing. The first CV for population. Sigma divided by mu is mean, the mean of this data that was available, into 100 as a form of percentage. Okay, so coefficient of variance is a very simple formula. Again, sigma divided by, that is standard deviation, divided by mean into percentage. We normally deal with population, so it's going to be there. Probability is a very interesting one, and probability is what fourth year students, I believe, should know. Probability is the chances of a number, or chances of a certain range or data that is expected to appear again and again. Like for example, there's a classic example of head and tail. There's a coin. The probability of, because there are only two sides of it, the probability of head is 50 and tail is 50. If you flip the coin, you would get either a head or a tail. So that gives a probability of 50%, right? In terms of a dice, because dice has 6 sides and 6 numbers, the probability of 1 is 1 upon 6, and we divide and get the number out of it. So probability is the chance that we have. How many chances out of the circumstances that we have? There are 2, that is the environment of the circumstances. It's 1, so then it comes to 50%. If it's more, then it keeps on dividing. So probability is the chances, approximately available chances that we have for a number to occur, a data to a set of data, right? So probability is something that you should know and be able to calculate. Again, standard error of a standard error is not very, I think it's not very important from fourth year students' point of view. It's more important from reading journal article papers, research papers, and you usually see this number as SE is equals to this. It's an approximate standard deviation of a statistic sample population. The standard error is a statistical term that measures the accuracy with which a sample distribution represents the population by using standard deviation. In statistics, a sample mean deviates from the actual mean of a population. Normally, we have a certain area of a certain, I would say, a chance of an error that kind of occurs when we are doing standard deviation. When you calculate standard deviation, especially on Excel spreadsheets, it usually comes as minus 0.00000. And when we calculate the mean of them, that is the mean standard deviation, there's a chance of that coefficient minus 0.0001. So that is called the standard error, and it is normally calculated in terms of huge statistical data. Bigger the data, the more the chance of standard errors that we have. Again, it's not very important from fourth year point of view. You should just know the basic formula, but it kind of appears in research journals and articles if you're reading them. So you should know what they are talking about and be able to understand. So the formula for it is sigma, again, the standard deviation, divided by number of, small n is number of samples, big N, the uppercase N is basically number of population. So you need to understand the difference. Sample is a set of data that is present. Suppose I would say vitamin D levels 3, 4, 5, 6. They're present in a sample of a population. So that would be represented by N. But if a population itself is presented, we had a number of, I would say, 500 is the N number sample, the main population number, 500 people, 500 male, 1,000, 10,000 men, women, children. So that is the number of the population, the number of people we are researching on. So that is capital N, uppercase N. Okay. The Chi-square statistics and distribution for different purposes. The Chi-square, I just wrote it here because it's kind of in the book, and you should know again what the formula is. But it hardly appears in the examination, nor it is used. It's a formula of calculating basically a value for the statistics analysis. And it's usually a higher level. Even in my master's level, we hardly use them. We use normally the T value or the Z value. I've written here again because those are higher levels and it doesn't really count. T values, small t values, I'll just give you an idea, are for sample sizes that are small, less than 30, less than 50, normally less than 30. Capital T values you would see in Excel book, community work, community textbook. The capital T is used for bigger sample size, that is more than 30 sample size. Suppose there are a number of people that are more than 30, or the sample that we are supposed to calculate is more than 30 samples that we have. That is used for capital letters. But again, Chi-square, I've written, if you want to just go through it, what it stands for, what it's used for. It's basically a way to show a relationship between two categorical variables. Suppose there's a numerical variable and there's a non-numerical variable. So the Chi-square statistic is used for countable and categorical. Suppose there's a frequency, and you want to show the relationship between the frequency and blood pressure levels, how many times between men and women, that would be the countable variable. And categorical, something that we would say a blood pressure would be the countable variable, and non-numerical categorical variable would be gender, males, females, 1:2 ratio. So in that case, we use the Chi-square statistics, and we show the relationship between. Again, it's a higher class, just go through it and see the formula. It hardly appears in the exams. So normal distribution curve, this is an important one, and it tends to appear a lot in the examination. Other than that, it's how usually researches are based. You should know what the distributions get. A lot of times our data is presented, once we have the complete set of data, it's presented in the form of a curve, and that bell-shaped curve, that is called the normal distribution curve. And the middle section, the exact middle of that curve, the highest point of that curve is considered as 0, and the right and the left are 50%. And as soon the curve flats out, the lesser its percentage or the value becomes. And usually at the tails, it is the smallest, that is 0.1. At the top of the bell, the peak of it, it's 0, and then 0 to 50, and then 25, 30. This is how it comes down to the tail as 0.01. Again, it shows that the central value, it shows as a starting point, just like in graphs we have a 0 point. So the center is considered 0 point, left and right with no bias, and it gives a sample set reading of data. So a normal distribution curve is important. You should know that it is a bell-shaped curve that represents a set of data, and it starts from the middle. The peak is considered as 0 point, left and right, they shallow down the values. So those were important, some of the formulas that you need to know, not really calculate. The calculations that you would be having in your examination, I'll go through it again. Mean, mode, median, you know them. Just go through just go through a textbook as well, or the slides, enough. Just go through how to calculate them. Even if in your exam you get them, they're very easy. You can just calculate them. The rest, just the formulas are enough from fourth year medical point of view. And in reading journals, you should know what they are talking about. And lastly, what is statistics actually BioStatistics used? The BioStatistics is used to generate a hypothesis. This is the most important component of biostatistics. Why do we study this in community medicine? Because it is the basis of generating a hypothesis. And what is a hypothesis? It's a possibility or a considered relationship between two variables. For example, there is a strong relationship between health and education of a population. The higher the education, the higher the lower the health risk factors, or vice versa. So a proposed idea between two variables or two detriments is called hypothesis. Okay, hypothesis is an act in statistic where, if you see the definition, an analysis, test, an assumption, an idea, as I said, regarding a population parameter. Again, you would be doing this later, but we should know what a hypothesis is, and later on you would be presenting it yourself as well. Null hypothesis and hypothesis alternative. These are two terms you should know. Null hypothesis, I've written down in the numerical form, is presented by H not 0. So if you're reading a set of data and it says H not, that means it does not have the possibility. Suppose if I said, what is the null hypothesis? Suppose that I present a hypothesis to you that there's a strong relation. I think health, education, is directly proportional, or education has a very strong effect on mental health of students, or the higher educated individuals are more likely to be depressed than lower, less educated people. So that is my possible hypothesis. That would be presented by H1. And H naught would present as no. That is, if it comes as a cross, that no. So first of all, let me explain again. A hypothesis, for example, I just gave you an example that higher education is strongly associated to depression levels in students or in individuals. Okay, a group of people. For example, we will take, in this hypothesis, we will take a group of people who are going to be either masters or postdoctoral degrees, fellowships, and we're going to calculate the set of data for them. We're going to take the set of data, the depression scale that we have, and we're going to calculate the correlation between them. So we say that it's less than 1. Normally we say, or more than 1, more than 3, whatever the data presents. If it proves according to that value, that means the hypothesis is correct. Suppose here it says assumption, a numerical that is used, the average number of TV sets in US homes is at least 3. So this is a hypothesis. It's always about, so if it's 3 or less than 3, then it says that the hypothesis is correct. But if it is not 3, it's more than 3, we would say. If it comes, the number that we calculate is more than 3, then we would say, no, the hypothesis was wrong. It is a null hypothesis. The average number of TV sets in US homes is more than 3. And the hypothesis would be regarded as null hypothesis. So it's a term and a variation. When a hypothesis is presented and it is not able to prove itself, we consider it as null hypothesis. But when we present the hypothesis, we present both the hypotheses in terms of our data, because there is always a possibility that whatever we are researching for, if it is present or it is present not. So that not is the null hypothesis. The alternative, the other hypothesis is the possible hypothesis, right? So this is all just a short basic concepts, measurements, and formulas for biostatistics from fourth year medical point of views. A quick one just to give you what is relevant and not to dive in very deep. It's not something that you need to know a lot at this level. Mean, mode, median, I would say again, then how to calculate them, very easy. Very simple calculations. The rest you need to know the formulas, just because you should know, if you are studying a journal article or if it comes an exam, what they stand for. And they are very super easy, nothing big, some basic concepts, you're ready to go. So thank you so much. Hope you enjoyed it, and I'll see you again with more details, something that needs a wider explanation. So I would go for that. Thank you so much for your time. Best of luck for your exams, and hope you find this interesting. Thank you.